Okay, so today we are wrapping up Unit 3, the dosage calculation. So we will have Unit 3 test on Monday. So we need to finish up some of our safe dosage calculations today and do a little bit of review. So we've talked about safe dosages. The biggest place that we talked about those was dosages based on weight. So let's look at some examples of that. Let's say we have a doctor who has an order of 50 milliliters Q3H. Q3H means every 3 hours. For a patient that is 110 pounds, and our label says that our recommended dose, 8 to 10 milligrams per kilogram every let's make sure I get this right here. Per hour. And it also is constituted at 50 milligrams in 4 milliliters. So let's see if this is a safe dose. Our first step is always turn the patient's weight into kilograms. 110 divided by 2.2 gives us 50 kilograms. So now from that 50 kilograms, we start our dosage calculation. We can either pick the minimum or the maximum. I usually pick the maximum. That's generally the more urgent of the two. So it's going to be 10 milligrams per kilogram. Kilogram has to go on bottom, so it cancels out. 10 milligrams per 1 kilogram. Now we need to get rid of the milligrams because we have to get to the units on our doctor's orders of milliliters. So we'll use this equivalency. Milligrams on bottom, 50 milligrams in 4 milliliters. And now we are in a unit of milliliters, so let's go ahead and multiply these out. 50 times 10 is 500, times 4 milliliters is 2,000 milliliters. 1 times 50 is 50. We divide that out, and we get 40 milliliters. Now that is 40 milliliters. We have to look at our time. That is per hour. This up here was per 3 hours. So let's titrate that. Our 40 milliliters, we have it calculated as per 1 hour. We want to change it to per 3 hours. And yes, I do realize you could have just multiplied that by 3. Gives us 120 milliliters per 3 hours. That's our max dosage on the 3-hour spread. Now let's look at the minimum dosage. Take that 120 milliliters. That was calculated using the max dosage of 10 milligrams per kilogram. We want to convert that to the minimum of 8 milligrams per kilogram. So 120 times 9 divided by 10 is 96 milliliters every 3 hours. So our recommended safe dosage here is 96 milliliters to 120 milliliters every 3 hours. I'm guessing that noise is coming from Prentice. If it doesn't quiet down soon, I'll call and have somebody go and shut off their system. I know they're gone for a career day today. So the safe dosage is 96 to 120 milliliters every 3 hours. The doctor prescribed 50 milliliters every 3 hours. So that's something that may need to be checked into. Couple of things there, by the way, that may have played into that. If we go, let's say we have a dosage that is recommended 100 milliliters every 4 hours. Mathematically, it's equivalent to convert that to 200 milliliters every 8 hours, because that comes out to be the same amount over, the period of a day. However, medically, there can be some issues with that. It depends on what's called absorption rates. Now, we're not going to get into the math of absorption rates. Absorption means how fast that medication gets into the bloodstream once it's administered to the patient. If it's IV, of course, it's in the bloodstream instantly. If it's taken orally, there's absorption rates. It's a matter of time of how quickly it gets into the system. Even intramuscularly, an injection intramuscularly can take time to absorb. If this is a fast absorbing medication, that smaller dosage at regular periods is usually more recommended. That higher dosage, spread out more, there's oftentimes it's fast absorbing. That higher amount absorbs into the bloodstream too fast and it's more than the body can handle, so it can be damaging. So it's always okay if I recommend, or the recommended is 200 milliliters every 8 hours, Q8H, it's okay to change that to 100 milliliters every 4. Bless you. I shouldn't say it's always okay, it's always safe to do that. It is not always safe to go the other way, where if it's recommended to do 100 milliliters every 4 hours, to change that to being 200 milliliters every 8 hours. Because that 200 milliliters all at once could be too big of a shock into the system. So splitting it into smaller doses more frequently is okay usually. It's not harmful, it's safe. Into larger doses less frequently is sometimes a problem. So anyway, I'm going to stop rambling on about that. I'm going to give you guys an example to work on. In your notes, I want you to try this one. The doctor orders 12 milliliters every 4 hours, Q4H, for a patient that is 55 pounds. The label says 4 to 5 milligrams per kilogram per 12 hours. And it also says 25 milligrams in 8 milliliters. So I want you to find the safe range of dosage and tell me, is that doctor's order safe? I'm going to give you a couple minutes. Background noise killed here. Our first step, again, is going to be change their weight to kilograms. So 55 divided by 2.2 is 25 kilograms. So we're going to start out our calculation of the 25 kilogram patient. Our first step, we're going to choose whether to use the minimum or maximum. I almost always choose the maximum, 5 milligrams per kilogram. So 5 milligrams per 1 kilogram, so that the kilograms will cancel out. And then we have to convert it into milliliters because that's the doctor's order. We have milligrams to go on bottom, 25 milligrams and 8 milliliters. 25, 28, there we go. The milligrams cancel out, and now let's just multiply everything up. 25 times 5 times 8 is, what is it, 1,000 milliliters. On bottom, 1 times 1 times 25 is 25. That divides out to be 40 milliliters, our time frame is 12 hours, per 12 hours. This is ordered every 4 hours. We are going to a shorter period of time, so that's generally safe. So we're going to take that 400 milliliters. It's currently over 12 hours. We're converting it to over 4 hours. We're doing that titration. Remember, the bottom number is what we've used for this calculation. The top number is what we are going to change to for this number. So 400 times 4 divided by 12, wrong button, gives us 133.33 milliliters. Again, we're going to round to always 2 decimal places when it's milliliters, milliliters per hour or so on, milliliters per minute. So that is milliliters per 4 hours. That's the max dose. And let's find the minimum dose. Take that 133.33 milliliters. That's calculated on the max dose of 5 milligrams. We want, what's that? Here? Oh, you are correct. That should be 40. Thank you. Got to move some decimals. So that should be 13.33 would be our 4-hour dosage. That makes more sense. Thank you. So then down here it is 13.33 being converted. We use the 5 milligrams per kilogram to make that. We want to see what it would be at 4 milligrams. So 13.33 times 4 divided by 5, 10.67 milliliters. So our safe dosage there is 10.67 to 13.33 milliliters every 4 hours. And the doctor's dosage of 12 is right in the middle of that. So their dosage checks out. Other than my silly math mistake, does anybody have any questions on that one? Okay. Let's do another example with you. We're going to switch over to doing an IV example. See what you guys remember on our IV calculation. So we have an order here. Doctor's ordering 20 drops per minute. For a patient that is 66 pounds. Our label, 8 to 10 milligrams per kilogram per hour, 25 milligrams in 8 milliliters, and a drop factor of 12 drops per milliliter. Find the safe dosage here. Now, this safe dosage is going to be in drops per minute. It'll be a range, of course, in drops per minute. Find the safe range of dosage here and compare it to the doctor's order. I'm going to give you a couple minutes again, see what you remember about IV flow rates from Monday. Let's see where everybody's at with this one. So once again, we do have to start out converting our patient's weight to kilograms. 66 divided by 2.2 is 30 kilograms. So we'll start out our calculation for a 30 kilogram patient. So again, we have to get rid of the kilograms. They go on bottom. We're going to use the max, 10 milligrams per 1 kilogram. Then we will convert those milligrams into milliliters. We have the 25 milligrams in 8 milliliters. So we're now in milliliters. Next step is to convert milliliters into drops. So milliliters on bottom, we have 12 drops per milliliter. The milliliters cancel out. It's per 1 milliliter. So let's go ahead and multiply this out. We have 30 times 10 times 8 times 12 is 28,800. Drops over 1 times 1 times 25 is 25. So 1,152 drops. Well, what's our time frame here? That is per hour. So we need to convert that drops per hour into drops per minute. So the hour is going to go on top, going into 60 minutes. Our hours cancel out. 1,152 drops over 60 minutes. We divide that by 60. Gives us 19.2 drops per minute. That's the maximum. Our minimum take that 19.2, we're going to titrate it. We use the 10, we're going to change it to the 8. So that's calculated off the 10. We want to adjust it to be off the 8. So 19.2 times 8 divided by 10, 15.36 drops per minute. So the safe range or recommended range of dosages here would be 15.36 to 19.2 drops per minute. Our doctor had ordered 20 drops per minute, which is slightly outside that range. So there'd be a case again, if you were administering that medication, you'd want to double check with the physician to make sure they were okay with that dosage. Okay, so last class, we talked about body surface area. So let's do some safe dosages with body surface area. So we have an order for 2 milliliters every 8 hours for a patient that is 70 pounds and 47 inches tall. We have to have both now for body surface area. The label states 7 to 8 milligrams per meter squared per day. And it is 5 milligrams in 4 milliliters of solution. We need to find the body surface area first. Our body surface area in meters squared is going to be the square root of our height in inches, 47, times our weight in pounds of 70. Now remember, because this is inches and pounds, we divide by 3131. Second square root, 47 times 70 divided by 3131. 1.025, 1.03 square meters we're going to round that to. So that's our body surface area. And that's what we're going to use to start our calculation. So 1.03 meters squared. We can convert our meters squared into milligrams. We're going to use the max, the 8 milligrams per 1 meter squared. Then we can convert milligrams. 5 milligrams is 4 milliliters. We'll multiply this out. 1.03 times 8 times 4, 32.96. That's milliliters. 1 times 1 times 5 is just 5. So divide by 5. That is 6.59 milliliters. The timing, though, is per day. So we need to now adjust that 6.59 milliliters. 1 day is 24 hours. The doctor's orders were every 8 hours. So 6.59 times 8 divided by 24 is 4.39 milliliters every 8 hours is a safe dose. That's the maximum dose. Let's find the minimum dose. That was calculated off the 8. Let's calculate down to the 7. So 4.39 milliliters. 8 is what we used. We're adjusting to 7. 4.39 times 7 divided by 8 is 3.84 milliliters every 8 hours. So our safe recommended range here, 3.84 to 4.39 milliliters every 8 hours. The doctor's order of 2 every 8 hours is kind of low. Something went wrong here. I did out of 12. That's what, okay. Something did seem a little off there. Did anybody catch what I did wrong? We gotta go all the way back up here. It's been one of those days today. Sorry, guys. 6.59 times 8 divided by 24 has to be a lot smaller than that. Times 8 divided by 12 is 2.196, 2.20. That sounds way better. So the maximum dosage is 2.20 milliliters every 8 hours. That's what we have to then titrate for the minimum. So 2.20 times 7 divided by 8 gives us a minimum of 1.93. So 1.93 to 2.20 milliliters every 8 hours is our safe recommended range. The doctor ordered 2, which is firmly within that range. Sorry about the mistake there again. It's been one of those days. Great example, though, of why you double check your calculations before you go to the doctor and question their dosage, though. That would have been quite embarrassing had you questioned the dosage and the doctor found that mistake. And no, that's not an excuse for screwing up. I didn't do that intentionally. That was just a mistake. Okay, so I'm going to have you guys try one. Hopefully your calculating goes better than mine has today. So our doctor is ordering 3 milliliters every 6 hours, so Q6H, for a patient that is 120 pounds and 65 inches tall. The label is 12 to 15 milligrams per meter squared every 8 hours. And it is 30 milligrams and 4 milliliters. So I'm going to have you guys find the recommended range for that medication and check to see if the doctor's order is in that range. I see a couple people still writing, but let's check and see how you're doing here. So we have to find the body surface area first. So it's going to be the height of 65 inches times 120 pounds for weight. Since those are standard units, it is over 3131. Giving us 1.58, we're going to go meters squared for a body surface area. So that's where we start our dosage calculation. So 1.58 meters squared. We're going to do the max dose of 15 milligrams per 1 meter squared. Canceling out meters squared. And then we're going to go from milligrams to milliliters, 30 milligrams and 4 milliliters. So multiply that out. 1.58 times 15 times 4 is 94.8 milliliters. And on bottom, 1 times 1 times 30 is 30. That is 3.16 milliliters. Our time frame there is for 8 hours. So at first glance, the doctor's dosage, the doctor's order looks safe, but this is per 8 hours and doctor's orders is per 6. So we're taking our 3.61 milliliters. That is per 8 hours, and we want to adjust it to be per 6. Gives us 2.37 milliliters every 6 hours. So we can already see the doctor's dosage is too high, but let's go ahead and find the minimum to complete that range. So what we have is calculated off of 15, and we want to go to 12. So times 12 divided by 15 gives us, we're going to round that to 1.90 milliliters every 6 hours. So the safe range for this medication would have been 1.90 to 2.37 milliliters every 6 hours. So the doctor's order of 3 milliliters every 6 hours is a little high. So we would need to double check that dosage with them. Anybody have any questions on the dosage calculations for weight, body surface area, or IV? Okay. So now we do have to be careful. I mean, we can throw some strange units in there. We can have a doctor that orders 2 grams over 12 hours. And if we look at our label, the label might say that this is GRIV per milliliter. Well, what does that mean, GRIV per milliliter? Well, GRIV means 4 grains per milliliter. If we look up, we'll notice that our, I'm going to double check just to make sure I've got it right even. There's a conversion between grams and grains. 1 gram, where are we? 1 gram is 15 grains. That's what I thought, but I can't remember if it's 15 or 60. So 1 gram is 15 grains. So we're going to have to first convert our 2 grams dosage here, 2 gram order, into grains. 1 gram equals 15 grains. So the grams cancel out, and we're now in grains. Then from there we can convert it into milliliters using this equivalency. 4 grains is 1 milliliter. So now we've got 2 times 15 times 1 milliliter is 30 milliliters. 1 times 1 times 4 is 4. We divide up the 4, because a 7.5 milliliters is how much medication we would administer to the patient. So in many of the examples we've used so far, we've done pretty standard units with milligrams and so on. But those other units that we've discussed can come into those calculations. Okay, last things I want to make sure we review a little bit before the test, and that is our dilutions. I know I've killed these a little bit, but dilutions are really the basis of most of what we do. Let's say, how about this? For a 2 in 9 dilution, what is the ratio of serum to saline? Well, the dilution is 2 in 9. But remember, in a dilution, that top number is serum. Well, that's part of what we want. But the bottom number is total solution, parts of total solution. So we want serum still, but we don't want total solution. We want just the saline. So it's still 2 parts serum. If we had 9 total parts, and 2 of those parts are serum, how many parts are saline? 9 minus 2 gives us 7 parts saline. So the ratio of serum to saline is 2 to 7. If 40 milliliters of blood is combined with 60 milliliters of saline, what dilution is performed? Remember, a dilution again is part serum over parts total solution. In this case, the blood is our serum. That is 40 milliliters. I'm including the units on there just to make sure they're the same and make sure they cancel out. Our total solution is not 60 milliliters. It's 60 milliliters plus the 40 milliliters of blood. So that gives us 40 milliliters over 60 plus 40 is 100 milliliters. And yes, the units do cancel out. I can reduce both of those numbers by 20 to get 2 to 5, or a 2 in 5 dilution. We might ask, how much saline should be added to 120 milliliters of 36% solution to dilute it to, let's go 8%. So now this is a case where we have a concentration and volume before and a concentration and volume after we've done a dilution. So before, and it doesn't matter which one we do, it uses before or after. Remember, our formula is C1 times V1 equals C2 times V2. It doesn't matter whether we let solution 1 or solution 2 be before or after. I always put the one that I know both numbers for first. So I have the 120 milliliters of 36% solution. 36 is my concentration. Now we mentioned before, it doesn't matter whether I put 0.36 or just 36, as long as both of them are done the same way. So I'm going to use 36 here for concentration 1 times a volume of 120. That means that when my concentration 2 has to be left as a percent as well. So that's 8%, so I'm going to leave it as just 8 times V2. And now I'm just solving that equation. So 36 times 120 gives us 4,320 equals 8 V2. And we'll divide by 8. gives us 540 equals V2. Now, V1 was in milliliters, V2 will be in milliliters. The question is that our answer? Remember, that's the volume of solution. There's 540 milliliters of that 8% solution. What we're asked to find in this problem is how much saline should be added to it. Well, we already had 120 milliliters. To get our volume up to 540, the difference is made up in saline, so we have to subtract. 540 minus 120 is 420 milliliters of saline is what is added. Any questions? And of course, the reverse of that could be true as well. We could say that 200 milliliters of saline is added to 60 milliliters of 24% solution. Find the new concentration. Well, again, I've got 24% and 60 milliliters. What's that equals? I'm looking for my second concentration for C2. I do not, however, have 200 milliliters. It's 200 milliliters that were added to the 60 milliliters, giving us a total volume over there of 260. Now I'm going to multiply the 24 times 60 over here, which is, I believe, 1440. And it is. And then we solve that equation by dividing by the 260. So we get 5.54% is that new concentration. Okay, that wraps up everything for Unit 3 here today. I have assigned pretty much all the homework to you for Unit 3. And I just want to make sure that I have given you on page 188 through 190 and page 196 through 197, do the odds on those. I'll be sending out your tests probably early Monday morning so that you guys will have them to work on. We'll have the whole class period on Monday to work on the test. You are allowed up to 2 hours for this test, but the second hour, again, you'd have to arrange outside of class if you need it. So you guys have a great weekend, and we'll see you on Monday.